Hello and welcome to NARC Live on Wednesday the 29th of October. No, sorry, not November yet. Panic set in. Of October 2025. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7ERP. Good to see you again. On tonight's show, Frank, W3LPL, joins us live to talk about the highly variable propagation that we can expect as solar cycle 25 is on the retreat. We take another closer look at the new Phase 2 and Phase 3 changes to Ofcom licenses. And we find out what on earth this is. And I don't think I'll be giving any surprises away to say that for the first time in a very long time, nobody has got this right. Am I allowed to say that? I probably shouldn't. But anyway, that's true. So if you know what that is, you have an opportunity now to pop it either onto BATC chat or onto Facebook and we'll read out your entries. Maybe you know what that is or what it's for. Anyway, back now to those license changes. And the reason that I'm talking about it again, and I did write quite an extensive article for the newsletter last week, is that quite a few people are acting on it. And there's a few people who've got kind of caught out with some of the things that if you're not careful you might trap. Now it's not for me to tell you all about them here, but there is a lot of information, and if you are for example now a full license holder and you're quite happy with your call sign and with things that you do and you don't intend to run any special event stations for example and things like that, then largely these may not affect you, but that you are able, for example, to change your call sign. So if you have a full license, you are able to change that to one that's available. You can change it almost instantly as well. But there are some dangers with that, and I just want to bring up some of those now because I know through some of you who've contacted me that you nearly sort of came a cropper on them. So first, if I can ask Tammy, maybe we can have a quick look at the place where we suggest you have a look at it. And this is the RSGB website. Although, of course, the license changes are implemented totally by Ofcom, the RSGB has not only got a useful link to the right place on the Ofcom website, but has also got some other useful information and guidance alongside, what I'm hopefully going to help you with tonight. As you can see, you can click on that there where Tammy is now. This is a live look at the website. And there it is. It's called Phase 2 and Phase 3 of the amateur license review, which we discussed at length over the last few years, and they suddenly came in on the 14th of October, as you can see there. As I said, if you don't have to act probably on anything particularly, but I'd like to just highlight some of the things that it will change. Firstly, if you do have more than one call sign, for example, if you have a full license, but you also have a foundation and an intermediate, then Ofcom have announced that you will be able to you will lose one of those. They have already explained that their intention is for people to only have one personal call sign. That doesn't affect it if you've got a contest call. So you see what I mean? It can affect all of you or most of you if you have something like that where those call signs could just disappear. I'm like that, for example. I'm a G7, which means that I got my license at a time when I could only a B license and I could only operate on VHF and UHF. Then the ability to work on HF came if I did a Morse assessment at foundation level, and then only if I used the foundation call sign. So I have a foundation call sign, and I'm going to lose that unless I do something and choose another call sign. So these are just options. I'm not advising you which way to go. The only thing I think I'm advising you based on some of the feedback is that some of these things could have some dangers, and I'll go into those in a minute. Now, one of the call signs, though, that the Ofcom are encouraging people to change, and that is the intermediate call sign. And you may remember that a couple of years ago when we really got quite actively involved with this review, and we had a big meeting at the CNS school to discuss it with members as well. And this is quite a contentious issue because many of you have 2E0 and 2E1. In fact, we have 40 members of this club are at intermediate level, and that's quite a lot of people. And they have an opportunity now immediately to change a 2E0 to an M8 or a 2E1 to an M9 call sign, which some people prefer, and they're looking forward to that. However, there are some of you I know who have 2E0 and 2E1 and they don't want to change it. That's their identity. They've got clothing with those call signs and things on there. So the moment the news is there, you don't have to change. But if Ofcom one day make it mandatory, if you want to retain your suffix, i.e. if you're 2E0 ABC at the moment and you want to retain the ABC, then I've only got, I think, a year to change over to an M8 or M9 to retain that suffix ABC. I hope that makes sense to you. So it's something to watch, something to think about. If you're happy with your 2E0 and 2E1 and don't want to change, that's fine. Just be aware, though, that the suffix that you've got at the moment, if you wanted to retain that and they make it mandatory, they're only going to prevent other people adopting that same suffix for about a year. That's the mention at the moment. So these are just the main sort of things that you can do. Now, I mentioned some of the dangers, and these are just because of people who've have talked to me about it and have expressed, horror really, that what could happen, and it's just something for you to think about. Do have a look at, by the way, at those Ofcom documents and the RSGB website as well for the real detail here. But there are a couple of people who changed their call sign, and I'll give an example. For example, one of our members is Tom G8XQD, and he has now changed it to G6TOM, which is understandable, and he's done that. Now, he has done that successfully, and I think he has no problems at all with that. But if you have your call sign registered with somebody like Clublog or Log of the World or QRZ, and you change your call sign and you change your identity, you need to be very careful that you don't lose all of the logs that you've got stored under your old call sign if you kind of make it disappear. Because your old call sign can't be adopted for, I think it's a period of 2 or 3 years by anybody else, but it will kind of cease to exist because you'll immediately, and I mean instantly, adopt this new call sign. It's done instantly over online. And once you've changed your call sign, you can't change it again for another 5 years. And this is the important thing. So before you make a change, just please read the detail. Read, the devil is in the detail, as they say, and please do read that Ofcom document very carefully and the guidance on the RSGB website. There are other things that affect, particularly makes it easier to get special event call signs that you can do online now yourself. And of course there are club calls and things like that, but they're the main things, and I'm only re-emphasizing all this really just because of feedback that I've had from some of you over the last couple of weeks since it happened. So watchword, have a look at the detail before you do anything. I really do recommend that you do that. Okay, oh, by the way, one other thing, yes, badges. The club is always happy to issue badges and give badges to members when they become a new member. Of course, we're happy to give a new badge. And also when people upgrade from, say, a foundation to an intermediate or an intermediate to a full. It's a kind of reward for the recognition for that. We are also going to give free badges for people who upgrade or it's not really an upgrade, is it? It's a migration to M8 or M9 if they wish, because that's kind of being encouraged, maybe not forced on them yet, but encouraged. However, if you change your call sign just because you fancy a change, they're sometimes called, not very nicely maybe, a vanity call sign, just like people have vanity number plates. I'm one of those, so I'm not criticising it at all. Then we will be asking you, if you'd like a new badge for your club, just to pay for that badge, which is £2.50. That covers the cost of the badge and a little bit towards the postage that we pay to get it there. So again, all these details are on the website. If you change your call sign though, whatever you do, please let us know, because we won't know about that. Ofcom don't have to tell clubs or the RSGB or anybody. So if you change your call sign, tell anybody who needs to know, and that includes this club if you're a member. Tell us what you've changed it to. Ask us if you want a new badge and you've changed it just because you like a change, then we will be making you a charge for £2.50, but you just need to ask us to order you a new badge. And also do tell other organisations like the RSGB and anybody else who's got your call sign, because they won't be told automatically by Ofcom. I think I've covered all the main things I wanted to cover there, and I hope that helps. Now looking ahead to Monday, a few days time, we're back to live streaming mode, and we've got tonight at 8, when this month, we're talking about improving speech clarity with DSP by Graham Somerville, M3ZGS. Now, you may not know his name immediately, but his company, BHI, you probably will. Graham actually, with his company, has supported Radioactive for very many years with various DSP speakers and adapters, and very kindly supported that for our charity. But also, these are excellent units to add extra filtering and extra DSP, especially to some of the older rigs which just don't have that built in. Well, there's a talk on Monday night which Tammy and I host for the RSGB. It's at 8 o'clock. You can find out all the details from rsgb.org/webinars, and you can find about how you can improve speech clarity with DSP. And one other little notice for you, I will be issuing booking forms in November, but I didn't think you'd appreciate me issuing booking forms for Christmas dinner in October. But our Christmas dinner is booked for Wednesday, the 17th of December. So it's on a Wednesday night. It's the Wednesday before Christmas. It's the 17th of December. It's at 7 o'clock, and it will be at the Village Inn. And I'll be issuing booking forms in the next couple of weeks. And they'll be online on the newsletters, and also you'll be able to pick up a paper copy as well at the club meetings. Now on to members news, and actually, to be honest, first time for ages, we haven't actually had any club member news from any of you. So please do keep in touch with pictures or anything that we can share with other members. So I thought be a little bit self-indulgent and talk about something that I saw a few weeks ago in London. As you know, probably, I've been fascinated with television ever since I was a kid, literally 7 or 8 years old, looking in encyclopedias, looking at the invention of television with John Logie Baird and the EMI system and all the rest of it to do with it. Well, I'm a member of the Royal Television Society, and together with the IET, they arranged a special talk by the grandson of John Logie Baird, who's called Ian Logie Baird, at the IET headquarters in London, just opposite the embankment there, earlier this month. And I managed to get a ticket to go along, and I took a little bit of video as well. So firstly, we'll just show you this picture. This is John Logie Baird's grandson, Ian Logie Baird. If you know a little bit of the history of it, you'll know John Logie Baird was a Scotsman. So I was a little bit surprised when Ian spoke, because he's a very, very much Canadian, and that's all to do with the way the family moved about. But anyway, he gave a really good talk about it. But as well as the talk, there was demonstrations there of practical demonstrations. They had people from the BBC, and they also had some young students from the University of Strathclyde who were challenged to build a modern version of the mechanical television that Baird invented. And there you see them. They've made them, recreated them really with wood and things, but they've used things like LEDs as well. I took a little bit of video. There was a lot of people in this room, but I managed to get a bit of video, and you can see the number of lines there. You could just make out that picture. If you look at it carefully in that little window, you just see a face, which, if you know your history of television, then you'll remember that there was a ventriloquist dummy called Stooky Bill, who was sat in front of a camera with very bright lights at the time. This is a sneak preview around the back. I'm not sure if I should have gone around the back really, but this is a video of just what these youngsters made, and you can see they've used LEDs to light the mechanical disc there. So they've slightly cheated there, but it is a mechanical Nipkoff disc, which is a spiral of holes, and how they did the first scanning of television. But it was a lovely effect, a wonderful tribute to mechanical TV. And Tammy, I'm sorry to just do it. Can we just move back a couple of slides and look at the one at the beginning, because as someone actually from the BBC said, no, the next one out long, that one. If we could just show that on the screen. If you like television, and if you like putting pictures and things on your TV, you'll know how frustrating it is when people take pictures in portrait style for TikTok and stuff like that. And I'm one of those people as well. I always turn the camera around, turn my phone around to take pictures. But as the BBC chap who came from the BBC Art Research and Development and gave a lovely talk, and as he said, though, maybe we should be respecting the fact that the first television pictures were actually in portrait like this, because as you can see, the picture was much taller than wide. Anyway.
Maybe they invented the telly the wrong way up then.
Well, maybe. But I always say to people, what way's your telly in your lounge? And until you get it on vertically, then I'm going to keep taking my pictures that way around. Anyway, a little bit of self-indulgence for me, sharing that with you. It's really wonderful to go to that talk in London. Really felt honoured. There was only 100 people there, so managed to get a ticket very quickly with the RTS. Tammy, that's enough from me. Little people with you.
Little people, have you ever wondered why you got 3 cameras on the back of your phone for?
What? Well, not really, but anyway, why?
This is why. Because one is a fishing.
Oh, he's fishing. Is that your phone?
No.
I hope that isn't water. If it is, it's going to cost us a fair bit, you know. I love it. It is good, isn't it? They're like sort of mill pools or something like that, aren't they?
Mm.
This comes from this Japanese website, miniature-calendar.com. I can see our guest here, just having a good look at that as well on his screen. It's a really good website. And Tammy picks a picture for us. Thank you very much, Tammy. So do, as I said, please keep in touch with us. Just send us a little bit of news. We are actually meeting next week, as I'll mention in a moment. I've got 2 NARC Lives in a row. So, you know, please, if you can get us some pictures or something that you've been doing in the summer, or maybe something that's happening now we're getting a bit colder, then please do send them to the usual address, radio@dcpmicro.com. We start putting the show together around about 3 o'clock in the afternoon next Wednesday, so it'd be lovely to hear from you before that. Now round to that competition when 2 weeks ago I asked you, what on earth is this, or what is it for? And as I said, it doesn't often fox you. I know some of you use the AI stuff on web and things to find out what things do, but anyway, let's read out. Has anybody
we've had
anything?
2 online, yeah.
Oh, have we? Okay.
Mike G8EEY says, is it a hat for a Mohican?
Well, it could be.
Could be.
It could be.
And
what did they used to say when the quiz people say, if it's right, I'll give you the money myself.
Yeah.
Just remember anyway, yeah.
I think this is a guess for it. Bob G6PWS. The what is it a fishing rod ties holder?
Right. Okay. I can't quite picture that, but I'm not a fisherman. So.
No, I don't know.
Nobody on BATC has commented yet?
No.
Okay. So these are the entries that we had by post. Thanks for those ones. Bruce G4KZT says, I think this is a vinyl record cleaner. KTEL, among others, sold them years ago. Yeah, I see what you mean. You could hold the record in one hand and then you just sort of spin it through your fingers with that.
David G3VSJ says, so what is your latest red thing? My plasterer neighbour had something very similar looking when he was smoothing over some render he did for me, but his was yellow.
Right. Okay, yeah, I think I'm feeling the word desperate comes to mind here. Now, Stan G4BW, he says, well, I've just got to say thank you very much for your entry, Stan. But I think, as you already know and understand, I can't really say what you thought it was because it was a little bit risky. But thank you for entering anyway.
Bob G8SDU, is this week's object a lock-in peg for a garden table leg?
And we can reveal that
Dun, dun, dun.
it's none of these things because it is actually a Korean hot pot protector. Richard G0VCW did that, and if we had prizes, Richard, you'd get one for foxing everybody because it's very, very rare. And I can see what they're for. They're like the silicone things that we have around. What do we have them for at home?
I've got a bacon tray with
that's it.
on the edge, and the silicone's already on there. But the trouble is, it gets too hot to touch. Anyways, you have to use your oven glove.
But anyway, that's what it's for. I don't know whether
it really works.
I don't know whether these bits are Korean or whether it's just the hot pot that's Korean. But anyway.
Well, you could hold any sort of bacon tray probably with that type of thing.
Very
but
good.
I don't think they're that good really because I think it's pretty hot.
Yes.
You need
I think if you put them on anyway, that's what they are.
Are we not allowed to debate how useful?
I think we're stretching the competition's brief to do that. But anyway, thank you, Richard, for doing that. Well done, you foxed everybody. Let's see how you get on with this one then. This is one I've just received actually in the last couple of days. I won't tell you who it's from because it might help. But have a look at this and you've got just under a week to tell me what on earth is this. No clues, no pack drill. All right, have a look at that. We'll put it onto Facebook. We'll put it onto the newsletter as well. And you've got just under a week to let us know. If you know what that is, then drop us an email to radio@dcpmicro.com. We're nearly ready to meet tonight's guest. But before that, just to go on, tell you what's happening at the club this coming week. So on Sunday, we've got the GB2RS News on GB3MB at 7 o'clock. And then on Monday, the Monday Night Net has started again. Thanks very much to Steve, G3EVA, who's at least kicking off the hosting of that from 7:30 on Monday night on repeater GB3MB. And then next Wednesday, November the 5th, which is, of course...
Guy Fawkes Night.
It is Guy Fawkes Night, but it's also...
NARC Live.
Yeah, we're here. So we're bankers any thought of going out to see any fireworks. But we're back here. I hope you'll stay. I hope you're here with us, because we've got Mike K3RFI, what a great call sign, and the do's and don'ts of power line interference. So if you think about that,
is one of the don'ts, don't set off fireworks.
I don't know. But I think it's quite I see what you did there. But K3RFI, radio frequency interference. And he's going to be talking about power line interference. So do keep in touch with your news, your stories. Of course, we're always happy to send this card to anybody who'll be cheered to receive a card from our club. Send it to radio@dcpmicro.com. Now, you remember that thing that we saw here in Britain a few weeks ago? It was called the sun. Don't seem to have got that now, but I tell you someone who has, and we're going to see him now. It's lovely to welcome again to NARC Live, Frank, W3LPL. Hello, Frank.
Hello, David.
Good to see you. And I mean, it was such a problem, wasn't it, when we connected up with you about 30 minutes ago, and you've got so much sun coming in from behind you. It makes us jealous. But it's not that warm, you said?
10 degrees Celsius.
Oh, well, that's not so much more maybe than here. Anyway, we're looking forward to you telling us. I remember we've had you join us several times over the last few years, and we were looking at Solar Cycle 25 coming, and now we're looking at it going, I guess. So I guess what you're going to do is help us make the most of it. And we're looking forward to your talk tonight so we can make the very most of as it starts to disappear. As always at home now, if you have any questions or comments for Frank, ask them during the talk, and we'll read them to him as well. Now, I think, Frank, actually, you will need to expand your presentation. I think we've only got it in a sort of... there we go. We've got it perfectly. So I'll leave it to you, Frank, and we'll join you at the end with any questions or comments that we've got. Thanks very much.
Okay, David, and good evening to everyone from Maryland, where it is a cloudy but fairly bright day at 4 o'clock in the afternoon. Daylight time. We switch over to standard time next weekend. This talk will focus on several things. One is to explain where we are in the solar cycle. A lot of people focus on solar maximum as a date, but it's actually a phase of the solar cycle. And just as an example of that, last weekend was the CQ Worldwide Single Sideband Contest, and propagation was fantastic. So we were fortunate to have solar maximum propagation about 2 years after the date on which the solar maximum actually occurred. We'll probably get about another year of very interesting propagation before it becomes uncommon. And I'll also talk about some hints about how to make the best out of a lot of variability over the next year or more. So I always like to point out a couple of places where you can get more information. This is a kind of a top-level talk, although it'll seem like it's not, but it really is. Propagation is an extraordinarily complex topic. The one on the right is a very readable discussion of radio wave propagation from ARRL, and the cost is not very high. On the other hand, the other two books are kind of reference books. They're about twice the cost of the one on the right. The ARRL handbook it has a very detailed propagation chapter. And of course, the antenna handbook covers the whole range of antennas for the entire spectrum of HF, VHF, and above. So all HF propagation originates on the sun, just as all human beings are on Earth because of the sun. We can't live without it. The solar cycle has 4 phases. We're still in the solar maximum phase, but very soon we'll be in the declining phase. And then probably in about 4 years, maybe 5 years, we'll be in the solar minimum phase. And around the year 2030, more or less. The solar magnetic field is the source of just about all of the things that happen on the sun, whether it's heat or light or HF radio propagation, which originates from the ionizing radiation on the sun. And it all has its roots in the solar magnetic field. The solar wind is very important in terms of HF propagation, understanding its variability. It's a continuous flow of hot magnetized plasma originating on the sun, and it's highly magnetized. So the sun's magnetic field extends out into the entire solar system, well beyond the planets, and it's known as the solar wind. And the interplanetary magnetic field is the magnetic field that is embedded in the solar wind. It's starting to, a more correct name is starting to become more popular, and we may start to see it called the heliospheric magnetic field, to make it clear that it's the entire heliosphere and not just the interplanetary part where the solar wind exists. But for the moment, we'll use the term that's been used for many decades, interplanetary magnetic field. Just like any magnetic field, the interplanetary magnetic field has polarity, north or south or somewhere in between, and that has a very big effect. And we'll talk about what happens when the interplanetary magnetic field is oriented southwards as the Earth passes through it. From the perspective of ionizing radiation, which gives us HF propagation, among other things, that ionizing radiation originates from the upper atmosphere of the sun, called the corona, where temperatures are unbelievably high, millions of degrees centigrade. There are features of the sun that are important to HF propagation. It's not just sunspots, but also active regions that contain sunspots, as well as coronal mass ejections, CMEs, which we'll talk about, and solar flares. Sunspots are concentrated closed magnetic fields, and that is that those magnetic fields originate on the sun and they return back to the sun. All of the strongest geomagnetic storms, and we'll talk about what they are, originate from something called coronal mass ejections. These are ejections of billions of tons of coronal matter, and they intersect the Earth and cause some pretty hectic stuff for HF operators. Coronal holes are a more common source of disturbance. It's the source of the high-speed solar wind, which causes some of the more minor disturbances, but they tend to be long-lasting. And coronal holes are, importantly, they're the source of the high-speed solar wind, which is the most common cause of minor geomagnetic storms. And lastly, in terms of disturbances, during the daytime, especially at this part of the solar cycle, solar flares can cause blackouts. Now, most hams don't even notice these because the most common blackouts last just a few minutes, but the most severe ones can last up to an hour and rarely more, and they can cause a lot of disruption to someone expecting to have a QSO with a friend on HF or operate a contest or whatever. Importantly, they affect only propagation on the sun-facing side of the Earth. either your location has to be on the sun-facing side of the Earth, in other words, daytime, or you have to be attempting to propagate through a daytime part of the Earth when one of these solar flares causes a radio blackout. So just a very high-level overview of some of the key features of the Sun-Earth system. The Earth is a very minor part of that system from the perspective of the solar system. But from our perspective as human beings on Earth, the Earth is a very big part of it, but in terms of the sun, it's almost insignificant. The things we care about most are sunspots, which are the cause of or the source of ionizing radiation. That's what gives us band openings on all of the HF bands, not just the higher bands. And of course, most of us are familiar with solar cycles, which are usually 11 years, more or less, but they can be as short as 9 years and occasionally as long as 14 years. It looks like this solar cycle is going to be right about 11 years. Too early to tell with any certainty, but seems to be on track to last about 11 years. Extreme ultraviolet radiation is the ionizing radiation that we care about. It causes the ionization of the F2 region that provides us with a long-distance HF propagation. There are other forms of ionizing radiation, perhaps most importantly, highly energetic X-rays from solar flares that can suddenly black out daytime HF propagation with no warning. Impossible to forecast these solar flares with any degree of usefulness. Geomagnetic disturbances cause degradations that can last from minutes to hours to days. We'll talk about that a little bit later. The sun's rotation is nominally 27 days from the perspective of radio operators. The important phenomena on the sun that affect HF propagation tend to repeat on about a 27-day scale. We'll talk about why that is in a little while. And then there's a seasonal variability, which has nothing to do with the sun whatsoever. The Earth's axis is tilted 23.5 degrees. That gives us the seasons. Well, we also get radio seasons for the same reason. So about this time of year, the HF propagation tends to be about the same just about everywhere in the world. Whereas in the winter, HF propagation is somewhat challenging on the winter side of the planet, but yet on the opposite side of the planet, let's say in Australia, they're having some really good propagation. So there's quite a very significant seasonal variability. October tends to be one of the very best months of the year, and we really enjoyed the benefit of that last weekend during the CQ Worldwide Single Sideband DX contest, where propagation was really remarkable, except on the 160 and 80 meter bands where both propagation was degraded, but that's the price we pay. So this is an assemblage of photographs from prior solar cycles illustrating the phases of the sun. So when we think about solar maximum, it's important to think about it as a phase rather than as a date. It will ultimately have an assigned date, and that assigned date is likely to be August of 2023, 2 years ago. But that hasn't been declared just yet. But we're very much in the solar maximum phase, but quickly getting out of that. We'll talk about that. And so we'll be entering the declining phase probably sometime in 2026 for sure. And that'll last for about 3 years. And then we'll be in the solar minimum phase. And that can vary in duration from 3 years to 5 years or more. So there's a couple of photographs of the sun illustrating some key features. I'll look at the right-hand image first of all during solar maximum. That's the phase we're in now. And you can see those bright areas. Those are known as active regions. And that's where the ionizing radiation comes from that makes the F2 region so helpful for propagation on especially on the 10 meter and 12 meter band. And also at night, solar maximum is very, very beneficial for nighttime propagation, especially on the higher bands. During solar minimum, sunspots pretty much vanish. They become very, very rare. And then this huge phenomena begins to appear on some days. And what you see in the left-hand image, it is what is called a coronal hole. And this is a very, very large coronal hole, one of the very largest ever photographed. It covers about 10% of the surface of the sun. It's huge, and it rotates at about 27-day rotation period, and some of these very big coronal holes can survive for about 6 months. Of course, they go around to the backside of the sun for about 13.5 days, and then they come back. And sometimes they are bigger, and sometimes they're smaller than they were the last time we saw them 27 days earlier. I'll show you a little bit more of that in a moment. In fact, right now. We're continuing actually to go through a 27-day recurrence of coronal hole number 116. They number these things so they can be tracked over time. And coronal hole 116 first made its appearance in mid-May of this year. And then it reappeared again 27 days later in June. And just look right in the center of these images, and you can see that coronal hole. And then 27 days later, it appeared again right here. And 27 days after that, it appeared here. And then on the 11th of September, it appeared as a very large coronal hole, but it's the same one. So it evolved from narrow, elongated shape in May to a grouping of irregular small coronal holes in July, and then reappeared in mid-September as a single supersized coronal hole. And it had big effects on propagation every time it appeared from May through September, and not very good effects either. Pretty severely suppressed HF propagation during the time that it was facing the Earth for about 13 days each appearance. So let's go off to a different topic of high importance, and that is the forecasts for the future of solar cycle 25. This image is dated the 5th of August, 2025. The website shown here is where you go to look at these updated every month on about the 5th of each month, but oddly the October one hasn't come out yet, and I looked at the September one and it was almost identical, so I didn't update the slide. But the October one might be a bit different when it finally appears, or maybe they'll skip October entirely and put up the 5th November one. So a couple of things of importance on this slide. So in the black line is the history of solar cycle 25 up to the present time. So it reached its peak a little over a year ago. I think I misspoke earlier and said 2023. I meant to say 2024. Nominally, August of 2024 is when it reached its peak of about 195, and then started a pretty steady decline. So in terms of the future of solar cycle 25 in the forecasts from NASA, they produce 3 forecasts every month. They produce one that is a very optimistic forecast. They call that the 95th percentile forecast. And they produce a still fairly optimistic forecast they call the 75th percentile. And then a nominal one, which is perhaps the one most likely to be true, with the 50th percentile one, the green line. And then a very, very pessimistic forecast which there's no evidence that we're tracking that forecast whatsoever. And if you look very closely at this graphic, you can see there's a fairly light gray line across the left side of the chart. And that is the daily variability of the sunspot number. But what's more often followed is not the daily variability, it's the smoothed numbers, which are shown in terms of cycle 25 history in black, and then the forecast going forward. Now, some hams have been thinking, well, maybe like the last few sunspot cycles, maybe we'll see a double humped sunspot cycle. Well, almost no chance of that, and I'll explain why that is in a moment. So the sun actually has two solar cycles, a northern hemisphere of the sun solar cycle shown in the purple color, and that's the southern, and then the northern hemisphere of the sun shown in that light blue color. And then those numbers are combined to produce a combined northern and southern sunspot number in the dark blue. And you can see clearly that the high sunspot numbers we've been enjoying for the last couple of years are dominated by the southern hemisphere sunspot cycle. The northern hemisphere solar cycle has contributed relatively small numbers, about 1/3 of the total of the combined sunspot number. And there's no evidence that the northern hemisphere is picking up its activity. It appears to be in decline. And here's one of the reasons why it seems extremely unlikely that a second peak in solar cycle 25 cycle is likely to occur. And that is, this chart shows all of the solar cycles from solar cycle 1 until the present time. And if we look at June 2025, that was the latest date, 66 months into the solar cycle, the latest date on which a second peak has ever occurred. And we're now 4 months past that. So statistically, over 25 solar cycles, there's never been a second peak that occurred after the 66th month. And there's no evidence that that statistic is going to get violated by what's happening on the sun today. And here's another illustration of the northern and southern hemisphere sunspot cycles and the combined cycle. And you can see on the right-hand side of this chart, that is solar cycle 24, which was a very weak solar cycle. It peaked about 11 years ago. And you can see, for those of you who experienced it, it was a very pronounced second peak that occurred about 2 years after the first peak. And that second peak was dominated by the southern hemisphere sunspot number. And if you look at all of these solar cycles of 21 to 24, they all had, well, 21 didn't have much of a second peak. But solar cycle 22 was double peaked, solar cycle 23 was double peaked, cycle 24 was double peaked. A lot of hams hope 25 will be, but I'm afraid they're going to be disappointed. It's not happening. I'm going to quickly, in the interest of time, just click through all of these. So what all this means from an ionizing point of view is variability of the F2 region. That's the highest altitude reflecting region of Earth's ionosphere. It's at an elevation of about 400 kilometers above the Earth. And it's the only region of the ionosphere that provides 24 hours per day long-distance HF propagation. Its ionization is greatest during the middle of the day, and it reaches its lowest daily value just before sunrise, but sunrise in the F2 region, not sunrise on Earth. The F2 region is 400 kilometers above the above the surface of the Earth, so its sunrise is about 2 hours before sunrise on the Earth. So the F2 region is starting to heat up and get ready for lots of good daytime propagation, and that ionization process begins about 2 hours before sunrise on the Earth. And of course, that's variable all over the Earth. So sunrise in North America is a whole lot different than sunrise in the UK. But still the same thing applies, and that is sunrise in the F2 region is about 2 hours before we see it on the Earth directly below. There's a great deal of seasonal variability in F2 propagation. 20 meters in particular during the daytime is severely affected in the summer, and almost all the long distance propagation on 20 meters vanishes during the middle of the day. And for any of you who are world travelers and bring radios with you, this phenomena of 20-meter degradation extends well beyond the summer if you're down in the equatorial regions of the Earth. Whether that's North Africa or in the Caribbean or in the Pacific, South Pacific regions near the equator, 20-meter daytime propagation can be frustratingly bad. In fact, propagation can be nearly non-existent when you're down near the equatorial regions in the summer and fall. In the winter, that problem tends to minimize. So there's no source of F2 ionization at night, but fortunately, the density of electrons is thin enough that it takes a long time for them to recombine with other atoms. So the ionization lasts throughout the night, but gradually declines until sunrise in the ionosphere, and then the ionization process begins anew. So there's a great deal of variability of F2 ionization with time of day, season of the year, depending on how the Earth is facing or facing towards or away from the sun, geomagnetic storms, which we'll talk about, and during the 4 phases of the solar cycle. And of course, we're just getting near the end of the solar maximum phase now. There's also a lower altitude region known as the F1 region that develops mostly during the summer, but its effect on propagation is relatively minor. Let's put up these other ones, so saving some time. Summer nighttime F2 propagation can be quite interesting. The ionosphere is very greatly ionized during the day, and that ionization persists throughout most of the night. So you can find that the 20-meter band, for example, is pretty much open all night long, but that's a good thing because 20-meter daytime is pretty terrible during the daytime, but it's quite excellent at night. And even during solar maximum, even the 17-meter band is often an all-night long GX band. A lot of hams don't know that and don't listen on the 17-meter band, but it can be remarkably good all through the night. And it's worth taking a look just to see what's happening. Let me just click through these other ones. Okay. And this is the phenomena that causes 20-meter long-distance propagation to degrade so severely during the summer and also down near the equator. And it's ionization of the E region, the same region where sporadic E occurs, and it radio waves that we're attempting to propagate up to the F2 region. Instead of getting up to the F2 region, instead they intercept the highly ionized E region, they get reflected there and never make it to the F2 region. Sporadic E often blankets not only 20 but also 15-meter long distance propagation, and it can be a little bit frustrating if you're a 17 or a 15 meter operator, but it is sporadic, whereas the daytime degradation of 20 meters during the summer occurs every day. Interesting form of propagation, and it's very prevalent during solar maximum, and we're still in solar maximum, but not for long, is long distance F2 propagation between very widely separated points. That propagation tends to follow the day-night terminator, and this is an illustration of a very common long path propagation we experience in North America between the United States and Japan. And why Japan? Well, there's a very large ham population in Japan. But from the West Coast USA, they get this same propagation, and it's focused mainly on China and Southeast Asia. And that propagation path is from North America down, skirting the Antarctica, and then, of course, Western Australia, and then into Japan. So this is another interesting way to look at sunspot cycle 25. It's a very creative image that tracked the total sunspot activity during the year 2024. And you can see all these different sunspots. And you can see how many sunspots there were on the southern hemisphere, significantly more than in the northern hemisphere. And that persisted throughout the year 2024. And shown in graphic form on the left is just how much the southern hemisphere sunspot numbers dominated the solar cycle during 2024. The red vertical line is the southern hemisphere on that chart, and the northern hemisphere is in green. But as we got to the end of 2024 and into 2025, the solar cycle was a little more evenly distributed between the northern and southern hemispheres. So let's take a look back at that NOAA website, the Space Weather Prediction Center, and take a look at in a little bit more detail as to what their forecast is for the future. The website is shown at the bottom of the page. And by the way, I'm sure David will make these charts available so you don't have to make detailed notes about all of this. Yeah. So the smooth sunspot number in November 24 was 185. That was pretty much the maximum that it reached. And then it has been steadily declining through the current dates. And in fact, it reached very low numbers in June 2025. It got all the way down to 130. But thankfully, it has peaked up again up into the 150 to 170 range. But you can see the forecast on the right side shows a steady decline. There's a great deal of variability in these numbers. And for the last week or so, there's been a lack of large sunspots on the sun. But fortunately, the medium-sized sunspots have been just active enough, and we're in the season of the year when the Earth benefits most greatly from ionizing radiation. So last weekend, we had an absolutely incredible CQ Worldwide single sideband DX contest, even though the solar flux index was down around 150. But unfortunately, you can see this forecast is for a steady decline. So we're down here around 150, and then we'll be in the declining phase of the solar cycle from probably middle 2026, maybe late 2026, and then for the next several years until we get down to about the 50 level. There's another aspect of the solar cycle, and that is the variability of degradations. So we have ionizing radiation that causes long distance HF propagation to occur, but then we have these degradations, and I'll talk about them in more detail. And this is the same organization, the NASA Marshall Space Flight Center, and their forecast for degradation over the upcoming 7 years of the solar cycle as we begin to approach solar minimum. And there's a feature of this I'd like you to focus on. And that is, even though we're now about a year past the date of solar maximum, notice how the degradations are continuing to increase in both the 50% forecast, the one in green, and the very pessimistic forecast in this case, the 95th percentile, that shows the degradations continuing to increase for the next 3 years, next 2 years, I guess, through the end of 2027 and early 2028. Well, the good news is that there's no evidence that we're on that blue line. It appears, based upon what we're experiencing, that we're actually close to the green line, the 50% line, which shows the degradations of HF propagation continuing at about the current level for another year, and then steadily getting better after that as we get into the declining phase of the solar cycle. Only time will tell if this forecast is correct, but actual events seem to support it. Just a couple of videos here. The one on the right is a sunspot. You can see the very dark region in the center of the sunspot, and actually the ionizing radiation comes not from that black region, but from all of the activity you see surrounding that very dark region. And in the lower left-hand corner is another little video clip that shows how the large sunspots change as they rotate across the visible surface of the sun. They change latitude. Their latitude increases a little bit as they cross, and sometimes the sunspots combine. Sometimes they grow, sometimes they shrink. And in the upper left-hand corner is the largest sunspot ever seen, and you can see that its size is bigger than the size of the Earth. That's a very rare event. It was quite some time ago, but it does occur. So let's talk about coronal holes just for a moment. Coronal holes originate from open magnetic fields that allow the corona's magnetized plasma to escape into space, forming high-speed streams of plasma that extend throughout the solar system, all the way to the edge of the solar system, far beyond the Earth. Coronal hole high-speed streams are the most frequent source of minor geomagnetic storms. And minor geomagnetic storms have become quite common. We've been experiencing some over the last couple of days. Fortunately, they are minor, and coronal holes rarely cause storms any worse than minor. It's the coronal mass ejections that cause the more severe storms. Coronal hole high-speed streams occur much more frequently during the declining 4 years of each solar cycle, and we're in that decline right now. And we'll talk about the importance of the interplanetary magnetic field in a little bit more detail later. But suffice it to say that just like any magnet that you might have, it has a North Pole and a South Pole, and the interplanetary magnetic field also has a similar orientation, either northwards or southwards or somewhere in between. And that orientation varies depending on where you are in where Earth is in interplanetary space. So as the Earth travels along, orbiting the sun, the Earth travels through areas of northward oriented magnetic field, and then it traverses into regions of kind of neutral magnetic field, and then into areas that are southwards. And when the interplanetary magnetic field is oriented southwards, it interacts with the Earth's magnetic field in some pretty severe ways. And that's when the strongest geomagnetic storms develop, when the interplanetary magnetic field that the Earth is traveling through is oriented southwards in the opposite orientation of the Earth's magnetic field. Coronal hole high-speed streams are also generally cause relatively short duration geomagnetic storms. They typically last for just a few hours. Sometimes they'll cause multiple geomagnetic storms, and we've been experiencing that over the last couple of days. Fortunately, at this part of the solar cycle, there's enough ionizing radiation from sunspots to wash out most of the degradations caused by coronal holes. As we progress through the solar cycle, the beneficial ionizing radiation from sunspots will become less intense, and coronal holes will tend to have a more severe and somewhat longer lasting effect. This image taken on April 21st, 2025 in the lower left-hand corner shows a huge coronal hole on the sun, 450,000 miles wide. And for those that were active on the HF bands in April of this year, it seemed like the minor degradations of HF propagation would never end. And the reason is that for almost the entire 13 and a half days that this coronal hole was facing the Earth, it was spewing out plasma that was intersecting the Earth almost continuously, and it just seemed like this would never end. And on the right-hand side is another image of another very large coronal hole, but that coronal hole had a much smaller effect. And why is that? Its east-west extent is much smaller than its north-south extent. The reason the April 21st one had such a huge effect is that its east to west extent was very large. And even though the sun was rotating about 13 and a half degrees a day, that coronal hole continued to face the Earth just because it was so large from east to west. Very, very unusual. We've talked about geomagnetic storms caused by coronal holes. The longer duration geomagnetic storms are caused by coronal mass ejections. These are ejections, they're explosive in nature, where literally billions of tons of plasma is forcibly ejected from the sun over relatively short periods of time, from a few minutes to an hour or two. Whereas coronal holes, they most commonly persist about 7 or 8 days, but they can persist for 6 months, as I showed in one of the earlier slides. So one of the important aspects of HF propagation variability is this 27-day repetition of large events. So days that tend to have very good HF propagation, and the CQ worldwide single sideband contest was one of the very best examples of that. That propagation tends to repeat every 27 days. And the reason is that the rotation rate of the sun at the latitudes where sunspots occur is about once every 27 days. The sun is a gas star, very highly magnetized gas star. And because it's a gas star, its rotation rate varies with latitude. And this 27-day rotation period tends to occur at mid-latitudes on the sun. And that's what causes the 27-day variability of very good days. Now, coronal holes, almost by accident, also tend to recur on about a 27-day cycle, but they do not originate in the coronosphere of the sun. They originate much deeper in the sun, well below the visible surface. And it turns out that the core of the sun, or the area well below the surface, also happens to rotate on about a 27-day, in fact, very accurately on a 27-day period. So both beneficial propagation as well as degraded propagation tends to repeat on a 27-day cycle. This is an image of some of the some large events on the sun. On the left side is coronal mass ejection, and these are often associated with solar flares, and they can release as much as 10 billion tons of magnetized plasma traveling throughout the planetary space and well beyond. And the speeds are just incredible, typically from 700 to more than 1,000 kilometers per second. So let's look at a few more aspects of this. Coronal mass ejections are the dominant cause of strong to severe geomagnetic storms. These are the storms that can very, very badly affect HF propagation. And shown on this graph in green is the daily number of fast CMEs. Fast CMEs are the most powerful ones. So during the solar maximum phase shown in the red dashed lines between 2012, this was for solar cycle 24, between 2012 and 2016, you can see during that peak period, there was typically about 4 to up to as many as 6 CMEs per day. But fortunately, CMEs tend to be smaller in interplanetary extent, so most of them miss the Earth, thankfully. The Earth is a pretty small little sailboat out there in outer space, and most of these CMEs miss the Earth. But when they do hit the Earth, and sometimes they have a very direct hit, the effect can be very, very severe on HF propagation, and it can last for hours to days. This is a very busy chart. And if those of you are interested in studying a chart like this, you might want to look at it a little bit later. But I'm just going to focus on a couple of key points. And that is, there are two primary sources of HF propagation degradation: coronal holes and their effect on the ionosphere, and CMEs, and it's the fast CMEs that have a big effect. So let's take a look at solar minimum, which is the top half of this chart. And you can see that almost all of the degradations occur because of coronal hole high-speed stream effects. Some of them are from fast CMEs, but the dominant cause is coronal holes during solar minimum. Right now, we're at the tail end of solar maximum, and take a look at the right-hand side for strong and severe storms, and you can see that almost all of them are caused by coronal mass ejections, and almost none by coronal holes. So that's a big difference, and there's a lot of statistics on this chart, and I won't dig into all of them, but that's the key takeaway, is that it's coronal holes during solar minimum, and you can see how often they occur, and fast CMEs during solar maximum. You can also see that there are many more severe degradations during solar maximum. So during solar minimum, there were 38 coronal mass ejections, and during solar maximum, there were 115. So there's a lot more, and they have a lot bigger effect near solar maximum. Solar flares, these are the degradations that cause daytime radio blackouts. and the most severe ones are called X class. We've had very few of them during this modestly active solar cycle 25. Probably not going to see a lot more, but we do get quite a number of M class. They're called strong flares, but they tend to cause effects that last for an hour or two, usually much less than that, and most hams don't even notice them. But during solar maximum or during the occasions when we have X-class flares, the effects can be dramatic. So these blackouts are caused by X-ray radiation. That's a form of ionizing radiation that ionizes the D region of the ionosphere, mostly during the years near solar maximum. And as I mentioned earlier, CMEs are the dominant cause of strong to severe geomagnetic storms, almost all of which occur near solar maximum, and we're slowly departing from the solar maximum phase. And in order for the most severe storms to occur, let me just click through the rest of this in the interest of time, requires that the Earth be passing through a part of interplanetary space where the magnetic field is oriented southwards, opposite from the Earth. And that's the period when there's a coronal mass ejection either going to hit the Earth or in very close proximity during a time when the interplanetary magnetic field where the Earth is traveling is oriented southwards. And this illustrates some of the effects for different storm levels. Thankfully, we have very, very few severe storms, but moderate storms are pretty common at this part of the solar cycle, and strong storms are not rare. The duration of these storms is highly dependent on how long the southward orientation of the interplanetary magnetic field survives. And you can see for the strongest storms, the interplanetary magnetic field needs to continue or being oriented southwards for at least 3 hours and sometimes even more than 4 hours. And here's another way to look at this. The K-index is a measure of disturbance of the Earth's geomagnetic field. KP of 5 is associated with minor geomagnetic storms. A very, very high percentage of these is caused by coronal holes, and it tends to cause unstable HF propagation that lasts for just a few hours. As the storms get stronger, for KP index of 6, these events are much less common than the minor geomagnetic storms, and they cause, just like the minor geomagnetic storms, most of their effects are at higher latitudes north of the UK. They affect propagation in Scandinavia much more severely than they do in the UK, and they last for several hours. And then, quite uncommon during this relatively moderate sunspot cycle 25, when the K-index gets up to 7, the degradations of ionospheric propagation can last for a day or two. K-indices of 8 are pretty infrequent at this part of the sun cycle, and we haven't seen 9 and are probably not going to see it. Here's another way to look at the same statistics, and that is how many days per year are we likely to have geomagnetic storms, and at what strength. And this goes through 2022, so just the very beginning of the solar maximum period. You can see that solar cycle 25 is relatively weak compared to the very much stronger solar cycle 23, but we've seen very, very few well, we've seen no storms of KP equals 9 and only a few days of KP of 8 during this cycle. And here's another way of looking at the same statistics. Recall that minor geomagnetic storms have a KP index of 5, so about 14% of the days are likely to have KP index of 5. And then going to KP index of 6, which is a moderate storm, that's about 5% of the days. And then for the strong storms, they're very uncommon. About 0.5% of the days get to K of 7. And here's yet another way to look at the variability of HF propagation, and that is the seasonal variability. Geomagnetic disturbances with a K index of 4 or 4 plus occur about twice as often during the spring and the fall as they do during the summer and the winter, and the statistics are shown here. So during September and October, we have about twice as many geomagnetic disturbances as we have during January and December. And yet another way to look at these statistics is during time of day. And that is and in this case, the K index is shown in this diagram as a heat diagram, where the red is the higher K indices and the blue is the very, very low K indices. And you can see that the high K indices tend to occur during April and October, and they tend to occur. I don't recall where on the earth this was taken, but suffice it to say that the stronger K indices tend to occur at night. So I think this is this may have been from Europe. So during the night, the most severe effects occur during the March, April, May period, during the spring period, and during September, October, November. And then just before sunrise, around 10 UTC, is when the very strong storms are likely to be nowhere near as severe. So here you see not only the monthly variation, but also the variation with time. And this is the same thing shown in a similar way, but it's the average number of days per month with a K index of 5, which is a minor storm or greater. And you can see very clearly in the statistics how much more often geomagnetic storms occur during March, April, and September, October. We got very lucky for the CQ Worldwide contest last weekend, where we had no indication of geomagnetic storm activity whatsoever. The effects of strong geomagnetic storms are much more intense after midnight, especially up in the auroral zone. So if you want to see aurora, for example, the time you're most likely to see it is after midnight. Now, I said most likely. Often the duration of these storms is very brief. So if the intensity of the storm is greatest around sunset, you may see aurora around sunset and then not see it after midnight if the intensity of the storm declines. This is a look at a map of the auroral oval. And the main feature that you can see here is that the solar wind causes the auroral oval to push away from the sun. So it's at a relatively high latitude during noon, local noon, and the aurora pushes down to lower latitudes at local midnight. And it persists at those local lower latitudes until almost sunrise. And the intensity of absorption tends to peak during the post-midnight period, especially as propagation passes through the auroral zone. The absorption in the auroral zone peaks during the midnight to sunrise period. So this is a look at another statistical look at solar flares. These are the relatively short duration events that cause daytime radio blackouts. This does not include solar cycle 25 data, but you can see how near solar maximum solar flares are relatively common, and during solar minimum, they become very uncommon. And the blackouts that occur are daytime only. If the Earth is not facing the sun, that area of the Earth is not affected by solar flares, only during the daytime. But that can affect radio propagation that passes through the nighttime, I'm sorry, through the daytime, the daylit part of the Earth. So if you're trying to, let's say the UK is in darkness, but you're trying to communicate into North America that's still in daytime, that propagation can be affected by solar flares in the daylit part of the Earth in North America. And this is another look at how often these flares occur. So this is a similar statistical look at the occurrence of solar flares. And you can see the X-class, the very strongest X-class flares, the X10s, occur only about 8 days per solar cycle, but this cycle is so weak that we're not likely to see an X10. And any X-class flares we do see are likely to be the 10 times weaker X1 flares. What we do see much more often are the M5 flares that tend to affect propagation for only tens of minutes, and most dams don't even notice that they occurred. So I'm going to close out the presentation with a quick look at propagation on the various handbands during the tail end of solar cycle 25. This solar cycle began to experience solar maximum propagation conditions about 3 years ago. And it's likely to continue, but with less and less reliability through 2026. So we're probably going to see some pretty good propagation on the HF bands right through the winter and into the spring of this year, but then become less and less reliable as we get deeper into 2026. Almost daily 10-meter propagation is likely to continue. As we get deeper into 2026, that almost daily will become less frequent. 15 and 17 meters, those bands are likely to be quite reliable for well through 2026 and perhaps well into 2027. 20 and 40 meter propagation, especially at night on 20 meters, and of course 40 meters is a nighttime band, is likely to persist at an enhanced level right through 2027. Most people don't realize that the solar cycle has a very big effect on nighttime propagation, a very big beneficial effect. And 20 meters is an all-night band, except during the deep of winter sometimes, but apart from that, it tends to be an all-night band. And that's likely to continue for a couple more years. The same with 40 meters is likely to continue all night long for at least a couple more years. So this is a look at which bands to use. 10 and 12 meters are likely to be great for the next 3 or 4 months as we go through the winter. And then they're going to suffer from seasonal variability as well as the decline of the solar cycle. 15 and 17 meters are fantastic DX bands. 17 meters is often open all night long at this part of the cycle. 20 meters is an excellent nighttime band. During the winter, it's also an excellent daytime band. 40 meters provides incredibly reliable nighttime worldwide propagation with simple antennas. Unfortunately, the 80-meter band suffers at this part of the cycle, but still, during the midnight period, it can be remarkably good. And I'm not going to read all through the slide. I've already made this point. But look for 10 meters to continue to be, and 12 meters to continue to be quite good through most of 2026. 15 and 17 meters for another year beyond that. And then 20-meter all-night propagation, perhaps through 2028. And 40-meter all-night propagation continuing through 2028. Now, as we get towards solar minimum, 40 meters is still a good nighttime band, but during the winter, the nighttime openings can be shorter. And the 80-meter band, of course, it gradually gets better, and it's likely to become significantly better after 2026. And the 160-meter band, that band has been pretty difficult, and it's probably going to be a couple more years before we see significant improvement. And the last couple slides right here, I like to use something called nowcasting. We're fortunate now that essentially all of us have access to the internet, and we have access to websites like the Reverse Beacon Network that show HF propagation right now. So you don't have to forecast what's happening. We can actually see what's happening in real time. This is a very easy website to use. You can look at your own call sign to see where you're being heard anywhere in the world, or any other call sign, or you can look at regions of the Earth. You can't break this site, and it's a fun site to experiment with. PSK Reporter is my favorite nowcasting site. And this shows one night when I got out 20 meters at 2200 Zulu, and you can see there was lots of 20-meter propagation that night. So that's the end of my presentation. It was like a fire hose, I'm sure. My slides will be available. I've already given them to David, and hopefully they'll be made available for people to look at in more detail for those who wish to do that. So David, back over to you.
Thank you so much, Frank. There's so much information there, and you're very kind to let us have that slide deck. So if you're watching this and you want to have access to any of those, it's not really a practical way that we can put that on our website, but just drop me an email, radio@dcpmicro.com, and there we are at the bottom of your screen now, and I'll forward them to you with Frank's blessing. So thanks, Frank. I mean, I'll start by just saying, by the way, as well, I've just been told that we have a problem our members watch this on two platforms, Frank. One is Facebook Live, and the other is British Amateur Television Club, which operate a lovely streamer. There are some privacy laws which have changed in this country, and we had an issue a few weeks ago where people who were not members couldn't sign it, couldn't make comments. The BATC kindly lifted that for us, but I'm afraid it's gone back to that tonight, and I don't know why. I have only just been told that, and I have emailed our friends at the BATC, but I'm afraid I don't think I can fix that for tonight. So just to apologise both to you, Frank, and also those watching. You know, we had 30 people or so watching on BATC, so I'm really sorry for those people who can't. If they're not BATC members, then they can't make comments, but I'll do my very best to get this sorted out for next Wednesday. Anyway, so some
David, I'm always quite willing to respond to questions by email, and there's my email address.
Oh, brilliant. Yes, thank you. Oh, right. Yeah. Okay, here we are. Yes, that was at the beginning of your talk, wasn't it? Okay, well, there we are. DonovanF@errols.com. It's always nice to obviously share questions, though, because they often have questions which are on the tip of other people's tongue. But thank you for that offer, Frank. I'll start by, we have actually got a question on from Facebook, a couple of comments, so I'll read those first. If you have got access to Facebook, you could have a look there and ask us if you've got a question. Tom, who's the gentleman who's just changed his call sign, actually, so he's now G6TOM, says that I didn't work Frank W3LPL, but I think I heard him recently and checked out the amazing antenna farm that he has. And what all he's asking really is, can he have some of those seeds, please, Frank? Just plant some more aerials like that.
There's a very big downside to a big antenna farm like that.
What's that?
Maintenance.
Sorry?
Maintenance.
Oh, maintenance. Yes, sorry. I thought you said Magnus. Maintenance, yes, absolutely, yeah.
Maintenance is a very big burden associated with having an antenna system like that. The elements are always working against you, and they don't occur necessarily on a schedule that's convenient for you. So be careful what you wish for.
And I guess that when the weather's the worst, that's when you need when the worst maintenance is needed, or the hardest maintenance is needed. But okay. Tom, anyway, on a serious point, says, is plasma hydrogen and or helium or heavier elements?
It's primarily, well, I believe it's mostly hydrogen. But you can find out answers to questions like this in detail on the internet. So I'd encourage you to look there. But the dominant chemical structure of the sun is hydrogen, and I think that plasma is mostly hydrogen. But I don't have a detailed recollection as to what the percentages of hydrogen versus other elements.
Okay, thanks, Frank. Another question, 2009, minimum geostorms, yet he managed a couple of contacts to Tasmania, which obviously for us is the other side of the world. What would have aided propagation? They had a very long wire antenna and only 100 watts. What would have helped them, do you think? I mean, maybe you don't have enough information, but...
Well, of course, I'd have to look at that particular date. But HF propagation, and just look at the title here, it's highly variable. And when you look at my presentation, that my presentation is focused mostly on nominal conditions and the long-term variability. But there's very large variability hour to hour, day to day. And sometimes we get very lucky. And last weekend was a classic case, CQ Worldwide Single Sideband Contest, right at the end of the solar maximum phase. And we had incredible propagation last weekend, better than anyone really expected. But everything just lined up just right. There were no coronal mass ejections anywhere near the Earth's environment. There were no coronal holes on the surface of the sun that were in geo-effective position to affect the Earth's ionosphere, and there was just enough ionizing radiation to make the F2 region quite good. Not perfect, but very, very good. Everything just aligned. And that's usually what happens, is that you hit it normally turns out to be about 5 days a month when the disturbances are at a minimum and the F2 region is ionized enough. And that's what we had last weekend.
Yeah, that's good. I heard it was good. And presumably most parts of the world had it good as well. So that was good, especially for that worldwide event. I mean, some people, Frank, would say that, what will be. And I suppose, well, I know there are some people who just enjoy the hobby because it's unpredictable. After all, if we wanted to make contacts with somebody specifically, then nowadays there's so many options to do that. So the fact that this is a natural phenomenon that gives us, is at least a large part of why we can make a contact. What do you say to those people who just say, well, what will be, and I'll just switch my radio on and see if I can make contact?
I agree. Ham radio using ionospheric propagation perhaps is more like experiencing a sailboat. Some days when the sailboat are absolutely wonderful, some days are absolutely abysmal. And a similar thing with HF propagations. It's about 5 days a month that are very, very good, and about 20 days a month that are pretty good, and 5 days a month that are just awful.
Yeah. I think that particularly, I think it was virtually your penultimate slide where you had a list of all of the bands. You know, I made a note of them: 10, 12 meters, 15 to 17, 20 meters, and then 40 and 80 meters at night and things. That'll be a really good, useful slide to have. Finally, can I ask you, not to get controversial and to get into maybe the political side of it, but climate change. We're used to seeing these more or less 11-year cycles. Do you think that climate change is going to make any difference to that?
Well, the Earth is so tiny compared to the sun that you can be sure that whatever is happening on Earth is not going to affect the sun at all. But it's possible that, and I'm just speculating now, that the constitution of the upper atmosphere might change, and that could affect how ionization occurs. But I think that's unlikely, but something like that might occur over a very, very long period of time. A question was asked earlier, which I couldn't give a very good answer to, as to what the dominant constitution of the plasma from the sun is. I think it's mostly hydrogen and possibly some helium. But on the Earth, in the Earth's ionosphere, the dominant source of molecules that get ionized are oxygen. Perhaps the constituents of the upper atmosphere might change over time, but there's no evidence of that happening yet. I'll just leave it at that.
All right, a good point to which to conclude. Frankie, thanks very much for joining us this evening for us this afternoon, as we can see with that sun glaring in for you over there. We look forward to seeing you again, I believe, in a month or two or something like that. A couple of months, I think.
Have you decided which one you want me to do?
I think I've left that up to our program secretary. So we'll see what Roger, who booked you for that, because he has an overall picture of the talk. So it helps to keep it balanced. That's the only reason, Frank. But we will be in touch with you very soon. I think it's in the new year, isn't it? Early in the new year.
I think it's in December.
Oh, is it December? Okay.
Yeah.
Right. Okay. Well, we look forward to seeing you again then, and we will have sorted out this problem where everybody can make comments and questions as well. But thank you very much for joining us again today, and we'll see you very soon.
Okay, David. 73.
7-3. Thanks very much, Frank. There we are. Thanks very much to Frank, W3LPL, again for a great presentation. Remember, if you'd like a copy of his slides, there's some really useful graphs and information on that, then just drop me an email and I'll be sure to send it to you. That's almost it for NARC Live. As I said earlier, we are meeting again next Wednesday. It's November the 5th, but it's Guy Fawkes night. I know, but you're going to see NARC Live, aren't you? Because we've got Mike K3 RFI with the do's and don'ts of power line interference. Of course, as well, on Sunday, the GB2RS News as usual at 7 p.m. on repeater GB3MB. And then Monday night, we've got Steve G3AVA kindly hosting the Monday Night Net. Is back again after a summer break. And that's also on GB3MB repeater at 7:30. And don't forget to keep sending us your stories and your pictures. It's lovely just to share those things with other members, and it gives us something to talk about as well. It's good. You don't want to hear what we're doing all the time. So please keep in touch. Until next Wednesday for NARC Live, from Tammy M0TC.
Bye-bye.
And me, David G7URP. Take care of yourselves. Look after each other. Bye-bye.